I think the first topic is Niels is going to be talking about the compositionality and more specifically how to evaluate or how to because in Monty we have those stacked LMs and we want them to uh, just basically look at objects and be able to evaluate the compositionality and figure out what that object is. So how do we evaluate that? It's not very straightforward. So Niels is going to be talking about the challenges. And then I think if we have time at the end, I doubt it, but if we do, we'll probably talk more about the behaviors. And I think Vivian has notes on the can worms, which is basically how to compensate for objects, object motion in the morphology model so that we can predict morphology features accurately. I think this is the topic, but also we may still talk about time if we have time. So, guess go ahead, Niels.
Cool. Thank you. Yeah, so I'll just get started. So I don't have slides, but what I've been doing is kind of putting together the document I was going to share. And it's not as polished as I was hoping. It's already 15 pages long and continuing to grow. Because there's just like a lot of elements and stuff. So I probably won't go through it in a ton of detail, but I thought it would at least be worth kind of going through at a high level and just talking about some of the things it discusses, maybe discuss it a bit now. And then if nothing else, when I do share it, it'll be a bit clearer, kind of why we're even talking about this stuff and what are some of the things to, I guess, for you guys to already start thinking about, because it might help us come up with some solutions. Because yeah, a lot of it is kind of open questions more than answers. Yeah, so as Rami was saying, it's all about kind of how we evaluate learning and inferring compositional representations. So like, how do we actually benchmark that? How do we convince ourselves Monty can do that? But also, how do we mediate that? So what do we need to do to enable Monty to learn and recognize compositional objects? And that includes kind of things like supervision, like, oh, we're going to tell Monty this is a child object with this label or whatever. But it can also be things that would kind of be out of scope of this in terms of implementation, but maybe more important than we realize, like things like attentional windowing and stuff like that. Yeah, so there's a mixture of just like notes as well, myself in here right now. Let's all focus on kind of some of the figures. I think this is kind of familiar to everyone. This is kind of what we mean about compositional objects and modeling them. So you'd have kind of, like a logo on a mug, but that logo could take different forms, and we can kind of very quickly associate these together. But in the long term, we might even have the concept of like a handle as being like a child object and things like that. But for the moment, we just want to get kind of a relatively basic version of compositional representations kind of emerging and being able to evaluate that. And for kind of a bit of context, right now when we have the single object scenario, we show an object, we put it in the habitat simulator. We know what object we put in the habitat simulator. And so the evaluation part is very straightforward. And we also know what pose it's at. We're just, I'll stop sharing for a second because I'm not pointing at anything on here. In that setting, it's very straightforward because we know exactly what the object is and what its pose is, and we can compare Monty's output representation to that and see how well it's doing. But as soon as we start adding multiple objects and creating our own data sets, so there's two ways we can know what the ground truth is and therefore evaluate. The simplest one, which we've kind of relied on in the past, is you just have one object that you're evaluating with. And so you know all its properties. As soon as you start adding multiple objects, we need to know what is the sensor module actually on, and therefore what should we expect the learning module to be observing, and like what would be the correct inference at that time, given what the learning module is actually seeing. And we can do that to a certain degree through what's known as the semantic sensor in Habitat. And I believe something similar might exist in Mujoku, where we can basically kind of read out, oh, okay, this is the object that the agent is currently, or kind of the sensor module is currently sensing. So part of what I've been trying to think through is kind of how can we still benefit from the semantic sensor, or how can we avoid needing the semantic sensor, or even if we have the semantic sensor, what are still some of the open questions about how we evaluate Monty? So going back to this document, and actually maybe just to kind of show, oh, sorry. Yeah, go ahead.
So when you say evaluate, now that we have two LMs,
Yeah,
we are going to evaluate at both LMs, or is it just a higher level one that we want to?
great question. So, I mean, that's part of the kind of stuff to think about. I think that one, I feel pretty confident saying we want to evaluate both LMs.
Okay.
Like higher level and lower level. It's generally more straightforward if we just focus on the higher level one. And so that's kind of part of what we can do, at least to begin with, is be more concerned with that. But yeah, it's I think those are the kind of things we just want to decide.
Okay.
But yeah, so just to show, and yeah, please definitely stop me any similar questions, comments. Yeah, just in case you haven't seen a semantic sensor before, this is a very rapid fire demonstration of that. So what you're seeing is the sensor and the kind of agent moving around in this multi-object environment. Sometimes the sensor module is pointing at the golf ball, sometimes the mustard bottle. And up here, you have this kind of label. And that is something we can get from the simulator when we have kind of multiple objects like this in the environment. We can actually read that out, which makes kind of evaluating a bit more straightforward. But to kind of start with, I think one interesting thing is that even if we have access to that information, so let's say, okay, we have a lower level column or, lower level learning module and a higher level one, they're both observing the mug with the logo. And let's say for now, they're kind of looking somewhere here. And in this first kind of setup, it's like, okay, we want the lower level learning module to represent the logo and the higher level one to represent mug. But it feels like a maybe equally valid kind of ask of the system is that the higher level one should be representing mug with logo. And this one maybe feels intuitively more correct. But then this raises interesting questions about, okay, how do we learn mug with logo without throwing away or kind of restarting, given that we already have a model of mug? How do we kind of branch that off?
The mug is in the lower level. Is it in the higher level also?
It's in in here I'm assuming it's in the higher level. But in general, then this is another issue. In general, we would kind of, or not necessarily issue, but the challenge, in general, we would want models to be in both levels, because you could have a mug that's a child of a logo.
So in the very beginning, like the first time we see the mug with the logo, we would definitely just have the mug representation in the higher level column. But then I guess over time, you would learn that compositional object and learn the association of where the logo should exist on the mug. And then I guess the question is, would that be an update to the existing mug model, or would that be like a new model that starts learning mug with logo?
Right. Yeah, exactly. And yeah, it feels like maybe kind of a branching of some kind would be a nice, like almost like a fork or a branch. If it was a repository where it's kind of like, okay, I'm not going to start over from scratch, but this is now a new object with this kind of prior information. But it's weird to think about from a biological perspective.
Yeah, it feels like that's just possible if we represent it as an object with different states. Like, let's say the mug can be in different states, and depending on what the L1 input or representation is, it expects certain features or doesn't expect them, and those could be the logo or no logo. So it seems hard to just make like a fork of an object, like a copy of the object, and then learn extra things on it. But maybe it's kind of something that both happens at the same time. Maybe the first time you see the logo on the mug, you're like, oh, this is the mug, but it's in a different state. Now it has some extra features here. And then, but then as you see it more and more often, or in parallel, you're learning a new model of mug with logo.
Yeah. Yeah, as in, well, how would it be, sorry, in parallel?
Oh, yeah, well, one thing I just thought of is, I guess if you learn it at first as a different state of that existing object, then, no, maybe not. Maybe if you then encounter them independently, if you can just assign a new ID to that state, a new object ID to that state, but then like they would still be sharing a reference frame, so I'm not sure how much that would make sense.
Okay, yeah. Yeah, as in, sorry, mug and mug with logo, or
Yeah, instead
like
of
have
being
different
like,
IDs.
oh, this is mug in state 1 and mug in state 2,
Yeah,
being like, all right, mug in state 2 gets its own object ID now. That
right.
does output from layer 2-3, because I've seen it
I
maybe.
guess if nothing else, the intersection of the state and the reference frame ID would give you a unique ID.
Yeah.
So like this is standard mug is kind of also its own ID because it's state 0 or whatever. And then, but yeah, in general, I like the suggestion of using states to kind of help with this. And then, yeah, in terms of kind of concretely what we do next, I don't think we have to solve this problem to begin with. I think we could already look at many interesting problems and things about representing compositionality and having that emerge just by kind of considering this situation where we do learning of the low-level objects in isolation, and we just see whether this happens. Because regardless, we need to do additional learning before we get mug with logo. And typically we just do.
If we just have the first scenario, we wouldn't have any compositional object. We would just be recognizing two different objects.
Yeah, it would be, but it would already be kind of hard or interesting, I guess, to see that you would have different learning modules recognizing different objects when they're kind of looking at the same part of the world. And then I guess the assumption is that if you then do further learning, you would get mug with logo.
I have to think about it some more. Intuitively, I would have said start with the second one. Be like, we never learn the just mug model. We just learn the logo, and then we see the mug with the logo on it. And in addition to storing the raw color values, we store the logo ID on there as well, and learn a compositional model. And that doesn't really, then we don't run into all these new issues of how do the two pay attention to different things in different areas in space, but we just look at modeling a compositional object, versus the first one is not modeling a compositional object. It's really more focused about these two learning modules pay attention to different parts of the world.
Yeah. Yeah, it's interesting. I guess the only thing is with this one, if we learn mug with logo without ever having learned mug, I'm just trying to think about what is the actual benefit of the logo. Like, are we really learning a compositional object, or are we just, I know we'll be passing the ID in, but are we actually using that in a meaningful way, or are we just essentially learning an object of the whole thing. And then there just happens to be this being associated each step, but this could just be random information we're basically passing in.
No, because when we recognize mug with logo, we can automatically make very accurate predictions about the logo itself with the feedback connections. And like, I mean, those are all the benefits of modeling compositional objects. The logo could exist on different objects as well. If you see the logo, that kind of informs additionally which type of object the higher level column is seeing. It's not just colors. It's not just light blue is on a bunch of objects. It's like, no, the logo is only on these objects on those locations. So I feel like storing that object ID of the lower column does help a lot with inference. And then it also helps a lot with predicting in the lower column about like how the logo, what logo features to sense where. I mean, isn't that, I feel like the second scenario is the whole modeling compositional objects idea.
Sure. I'm not saying we want to stop here. Definitely not. I guess I was just wondering whether this is a more constrained thing to start with. But I agree. We ultimately want, the kind of
Yeah, I mean, I guess
repetition.
the question is, do we need to do the first one to get to the second one? Like, do we need to figure out how to pay attention to different parts first before we can model compositional objects? I feel like, off the top of my head right now, I need to think through it more. I feel like we don't necessarily need to. And like, if we only do the first one, we are not modeling compositional objects yet. We're really looking more into attention. But I'm not sure. Maybe there are some arguments why we can't do number 2 without doing 1 first.
Yeah. So I guess generally when I thought of compositional objects, it's kind of, again, it's like you would have mug to begin with, and then you would learn mug with logo because you could have different logos. And so kind of if we jump straight into this, we'd have like mug with TBP logo, and that would be like a totally different object from mug with Numenta logo. That's,
but
again, it might be a useful stepping stone, but it feels different from.
I think it is a different object because in your cupboard, you have a cup with Numenta logo and cup with TBP logo, and they are separate objects. It's not like that cup ever transforms into the other cup. In my mind, I mean, I have both cups in my kitchen, and in my mind, they are 2 separate objects. Yeah, they share some morphological similarities and stuff, but I'm not sure if they need to be learned, if that needs to be represented in the model itself, or if it could just be like there's like a general morphology model of that big coffee mug type.
Yeah, like a different learning module that just knows generic mugs.
Yeah, right.
So for scenario 2, are we also learning the mug without the logo in the lower level?
I would argue we don't need to, at least not to investigate modeling compositional objects.
But then what does the sensor output? Like, what object ID do we store when the sensor is not on the logo?
I guess it could be mug. I mean, because then we could have mug with could be associated with points on the logo.
Oh, you mean the lower level column if that one learns the mug?
Yeah, the lower level, when it's not on the logo, it should output just a cup, like a mug.
Oh, okay. Yeah. Yeah, that one could have a model of a mug too.
Yeah.
I guess how would it not? I mean, if you're learning this TBP mug, the lower level is going to see the whole object, right? During learning.
Well, it could be that it's constrained in the size of objects it can represent. Like the lower level in the hierarchy might only be able to represent objects up to a certain size. And then it would maybe never learn a large object like the cup, but only small parts on it like the logo. But yeah, I don't see an issue with it being able to learn the mug either.
yeah, in some ways that would be better for evaluating this, because then we could basically see that we're binding a different object to different locations.
I think the question is how does the brain do that? Because it's only seen mugs with logos. How does it extract features that are only about the mug without any logos, so that it could just be in the lower level and use it with other logos?
Well, I mean, we can set it to start with. I would set it up that the lower level column first just learns the logo in isolation. Like the first time you saw the Numenta logo was probably not on a mug. It was probably on the website or something in a pretty isolated way. So you could kind of argue that you can learn it in isolation first, and then you can recognize it projected onto different types of objects.
Well, it's rare to see it in isolation. I don't know, maybe, but especially, like on the other hand, with the cup, with the mug, you only see it with logos. I guess
Is that true? In the real world, you see
I
normal
don't
bugs
know.
all the time.
I don't know.
I mean, if you go to our Thousand Brains website, it's pretty isolated up here. You can
Yeah.
just like there's a lot of white space around it. You kind of clearly see that something else starts down here. I mean, yeah, I agree. We probably need some mechanisms to do this kind of model-free segmentation and try and stay in that area while learning it. But yeah, I think should be too hard. I guess the second approach would be this kind of statistical approach of I'm seeing this consistent pattern, but on a bunch of different backgrounds. So the backgrounds get averaged out over time, whereas the consistent part of it remains in the model. I think that's
Yeah,
what we talked
and
like Rami
right.
Niels
I think it would be a
talked
mixture
about
of
last year.
probably a mixture of those, and I think that's something we can definitely weigh with, because that's a more general kind of unsupervised learning thing, which yeah, we definitely want to address. But I think just to like the kind of aims of this is really to see whether things like the location by location binding in the hierarchy, that's a proposal. Like, is that giving us what we believe it would in terms of being flexible about these compositional relations and predicting the appropriate thing in the low level? And that it's fine if they learned it in a kind of semi-supervised way where we showed, okay, this is one object. And yeah, I guess to your point, Vivian, then we can already kind of evaluate that kind of stuff with with the just having kind of a unique ID at the top for even like TBP mug with bent logo is kind of a totally different ID.
Yeah, I would argue that that's reasonable to say those are different objects.
Yeah, at least as a first.
I mean, unless you see it bend, I would say we classify those as different objects. Like if you see the logo rotate on the cup, yeah, then those are different states of the same object. But if you just see two cups with a bent logo and non-bent, I feel like we would say those are two different cups.
I don't know if this is helpful. If it's a tangent. If it's a tangent, just feel free to ignore it. But I think just hearing the supervised, and I think it might be a source of confusion trying to figure out what an object is, and I think it might be more approachable, kind of what Niels, I think Niels is saying, is like supervised, saying this is an object, this is an object. We are just testing compositionality here.
Yeah.
In just in a supervised manner. Because to like Rami's point, like whether we're learning C cups with logo on it or not, like I think that's all very fuzzy, and I don't think we know how we learn what an object is. I was thinking about through this conversation, we don't actually have a definition of what an object is. And so we can still experiment with compositionality by saying this is an object, how does the compositionality work, without getting caught in the weeds of what is an object. Because the immediate example comes in, I know what a tree is, but every tree is different, right? So it's like,
right.
you know, what is an object there, right? So we don't need to get into that to progress it. And I would just say, let's not get into that because we will confuse ourselves farther. That's probably a different problem to solve of what is an object.
It is
Right.
a problem. I just want to make a point of, like, the point I was trying to make is if we give Monty just a mug with one logo and we just tell it to learn it, it'll probably just learn this as one object. It's not going to need a compositionality until you see that same mug with a different logo. That's when it decides, okay, no, now I need a more compact representation. I need to extract the cup from the mug from the logo, and then so that I could use them on different things. And same for the logo. If it just sees the logo on that same cup, it's the same object. But once you start to see the logo on different places, then you start to say, okay, now I need to factorize that so that I could make a more efficient representation of the logo that can be used elsewhere. And I just wonder if,
But it
that
might
is-
start, I think it might start the other way around. You might first learn a bunch of different objects, like you learn about letters in preschool or school.
Yeah.
And you learn those in very isolated ways on paper and everything. And then you recognize those letters in a bunch of different places. You recognize the letters on the cup and stuff like that. And it could be very similar with other things. You learn generic models of cups and generic models of curves and letters and stuff. And then you learn the compositional models of them. I think it's very difficult to actually factor out totally new features that you've never seen in isolation before.
I would argue that this is like a special supervised case where you have like a curriculum learning approach to it, where you just focus on the little things and then you start building. I think that both of them are approaches to learning objects, but we also can't ignore the learning where we just see the object and then later on decide, no, it's breakable into different parts. Just like when we see the stapler at first, and then we say, oh no, it's two different parts, not just because of motion, but maybe because we saw that later on in life, we saw that part of the stapler on something else, or like we saw that handle on something else. That's
Yeah, I agree. We still need to solve the problem. But I guess mostly to what Tristan just said, I think we don't need to solve all the problems at once. So we could focus on just how do we represent compositional objects and how do we infer them based on those compositional models. Give ourselves a few crutches around learning, like supervising a lot and showing things in isolation. And then from there, we can move on to like, how do we do this with less supervision? How do we remove some of those assumptions during learning? Yeah.
I totally agree. Yes, no, I totally agree that just to validate the problem of compositionality, we need to tell both learning models, need to give a supervision of what is an object at which level, and just start to make those binding associations.
Yeah, no, it's definitely an important problem to get back to at some point. So I think that was already a useful discussion. So right now we can think more about it, but as you're kind of suggesting, Vivian, we start by, we would still learn the logo and the mug in isolation. But then we would learn TBP mug, for example, as a new object. And we can again provide a supervised label if it needs to be, at least to begin with. And then we can look at things like, kind of where we are associating locations on the logo with the location on the TPP mug and things like that. Which let me just write this down. Look, I forgot. Okay, and then so that was the opening figure because the question was basically, okay, assume we have access to the semantic sensor information. What would we actually be looking for at each level? And so for the high level, it doesn't really matter too much because no matter what data set we're using and stuff, if we're presenting the mug with logo, like the sensor modules in general are only, they're never pointing into the void. They move back onto the object when they go off into nowhere. So we're always going to be kind of looking at the mug with logo. So as long as we get that representation emerge here, like mug with TBP logo and not bowl with Numenta logo or whatever, then this one's correct. Yeah, go ahead.
Yeah, I'm just thinking about this mug with logo thing instead of mug. And like, you know, I know this is an edge case, but there are stickers and magnets. You know, you can put a logo on something and then peel it off and then put a different logo. And I don't want to overcomplicate things in the beginning, but just sort of like in the general case, like I think about like a dinner table, like talk about the dining set. If I take a fork off of the table, it's not an entirely new setting of, you know, the table and the arrangement of the table, right? Like it seems like mug with logo might be like overly constraining in terms of it being sort of like too specific for the exact setting that that we're trying to compose. Like it almost feels like it could just be too specific. Yes, my TBP mug is different from my Numenta mug. They are distinct items.
I mean, I think if you're freely combining objects with each other ad hoc, I feel like you wouldn't learn both the forward and backward connections. Like, if the fork can be anywhere on the table and it's still the dinner table, there's no way for you to learn, all right, well, if I'm on this location on the table, I expect to be at this location on the fork. So you certainly couldn't learn the backward connection if there's the constancy there. And I guess with the forward connection, it could, yeah, there might be a bit of tolerance to like features being at slightly different locations and stuff. But it seems like, yeah, you can see them at different locations, but maybe at that point you're really just recognizing the table and forks as individual items and not really a specific set dinner table model that you can use to make predictions about where things are on the table.
So there's like so does that mean that each dinner table would be its own? Or, you know, if I take the fork off or I move a fork around, now we have an entirely new object. Now it's,
I guess
Yeah,
it
I
depends
guess
on how much you've attended to the fork and how important that is.
I mean, it would likely be like a quickly learned model in the hippocampus or something that you can use to make short-term predictions. Like I just saw the fork over there, but and that I would say it would have its own kind of ID. It's not like you would say it's a different table now. That's still like the kind of stable table model you learned stays the same, but for the kind of scene representation you built up just now, I would argue it's not some generic dinner table ID. It's like, this is my dinner table right now ID.
yeah.
Yeah. So like one way to kind of describe it is that like in region 2, you would have many columns that are just representing mug when looking at this, and also some that are learning the specific instance of a mug. And so, and both of those can, I guess, help you inform how to act in the world or whatever. If someone asks you to pass the TBP mug, you know which one to pass. If someone asks you, hey, you have something I can pour coffee into, then any mug you can see right now is kind of valid.
And I guess one important thing to keep in mind is that there isn't necessarily like one output. It's like all of the learning modules can be kind of outputting different things. Some might be recognizing generic mugs, some might be modeling the logo, some might be modeling the mug with the logo, and those would all be correct and valid. interpretations of reality that can all be active at the same time. So it's not like there needs to be just one overarching classification.
Well, so I guess like it seems like we don't need composition. We don't need hierarchy to do mug with logo. We can just do mug with logo with a single LM. Like, but that's what we have now.
Well, the
So
point,
why?
the
Yeah.
point of learning a compositional model is that this now gives you a lot of predictive power and helps with inference in the future. Like if there is a constant relationship with the logo on a specific mug, like I have the Numenta mug here, and I know that the Numenta mug has the logo on the front and on the back. So even if I'm just seeing the front, I can predict very well what I will see if I turn the mug around because I've learned that model of this specific cup. If I see this for the first time, I would still recognize the Numenta logo. I would still recognize that this is a coffee cup, but I wouldn't be able to predict what's on the other side of it. Does that make sense?
But I think Scott's point is that, like, yeah, if we learn the entire object with the high level one, that gives us, I think unless we constrain the high level one in some way, like it gets coarser sensory input, or it can't, there does, I feel need to be something that's distinguishing the logo model in the low level column from the sort of logo submodel in the mug with logo model. If those are equally detailed, then it's hard
they
to.
wouldn't be equally detailed. The higher level model would get like larger, lower resolution receptive field input.
But that's like an important thing that we need to ensure is there. Otherwise, there won't really be a clear difference.
So if we do constrain them in terms of size or resolution or whatever, what happens when we want to zoom in on the logo and just look at subcomponents of the logo, like letters? Do we need to bring the whole thing much closer to our face so that the top level one, has, a good enough view of the logo itself? Like, we have to deal with nesting beyond 2 levels eventually. And I'm concerned that just to repeat what I just said, by constraining each by a certain size or resolution, that we'll like lose the ability to nest further down to the letter or even subletter level composition.
I may be missing something, but if you need to get details of the lower level, like low level details, you would just use the model that you stored in the lower level LM. Right, because that's the detailed model. When you stored the object ID in the higher level column, you could use that to basically figure out what the morphology model in the lower level LM.
But what if the logo itself is compositional? So it's not just a single thing, because the logo is compositional. It's composed of a bunch of letters, right?
Yeah. So I guess the idea there is that you would shift kind of what R2 and R1 is representing. And this is why it's important that both kind of learn multiple objects, in that at that moment when you're focusing in on the logo, R2 would actually represent TBP logo, and R1 would represent like letters or the TBP neuron thing.
And I guess the kind of attention shift is something we haven't really fully figured out. At least I don't know how we
right
implement that. But yeah, that's a good.
So if we're looking at the logo in isolation, for example, and we're just then in that case, in order to enable that behavior, R2 would be learning the entire logo while R1 would be learning the letters. Right?
Yeah.
But then somehow R1 is also going to represent the entire logo at some point when R2 is looking at mug with logo.
Yeah. And so during learning, they would potentially all be learning, like if you're learning the logo, R1 and R2 are learning the logo, but each with their own kind of flavor of model.
Mm-hmm.
if that's kind of, I guess, the level you're attending to. But then at imprints, that's where we were saying, like, we need a way to like sort of shift the attention. So that
like
you only at the low level get the child representation.
when we shift the attention, by that, do you mean the entire learned model is actually moving down the hierarchy? Because at some point,
no, because it would be at both levels. It's constraining.
I see.
So like, I think the example Jeff gave was like the mustard bottle with the French logo or whatever.
Mm-hmm.
That maybe initially, when you look at the mustard bottle, both R1 and R2 are saying, oh, it's mustard bottle. And then when you narrow in and look at the logo, R1's input is being constrained, maybe in a way that it's kind of like, oh, okay, yeah, there's something interesting there. And so it's getting kind of a more narrow constrained input, and it represents logo. Then R2 is still getting kind of a broad input and just keeps saying mustard bottle.
Okay, does that mean that theoretically during learning, R1 would learn TBP logo and mug with logo? Because it seems like
Right. Yeah.
that's what that would mean. And it would kind of mean that every lower level thing is learning sort of multiple levels of composition version of some object, while the higher ones, if they're constrained to size or resolution or whatever, learn fewer.
Yeah, or it would imply maybe that we also need some amount of attention at learning. Again, this is for the unsupervised learning to work, not necessarily the basic supervised setting. Because if we have attention during learning, then we can also say, okay, I'm learning logo, you're learning the letters, or I'm learning the mug with logo, you're learning the logo. We're not even learning, just representing. Yeah, it's almost as if learning maybe through attention only happens at one level, like building new models, and it can rely on inference happening in other learning modules. So if you're learning mug with logo at a particular level, if you already know the logo, the previous level isn't learning anything. It's just representing stuff that it already knows, like logo and mug. So it feels like that might help with some of
Yeah,
that.
if the lower model already knows the logo, it would just recognize the logo and not start learning logo with mug. And feed that as input to the higher level model.
Yeah. But yeah, maybe just another interesting example to think about, and this is actually a data set we could potentially work with, is the Omniglot Dataset, which, those of you who don't know, is a kind of data set of alphabetical characters from a bunch of languages around the world, including made-up languages like the alien alphabet and Futurama. And each letter has been drawn by, I think it's 20 different people. And so the idea is that, yeah, you can test generalization, but it's also a challenging data set because it's very small. There's very little training data. And so it'd be an interesting one to look at because Vivian had previously set up data loader so we can actually evaluate with it. And it is one that traditional kind of deep learning methods struggle with because of the amount of data. It's also, I think the Amazon Turks who were writing the letters must have been like writing with a mouse pad or something. Because like if you just look at the Latin characters, this is a G and a K. I think even as native, Latin alphabet users, those are funky.
For this data set, if we want to do it in a supervised way, we want to do we have the strokes? Do we have the low-level strokes? So that we can-
Exactly. So yeah, so the data set includes the individual strokes as well as actually tiny information about them. So you could also imagine if we do work with it and it works well, this could also come into like behaviors and motor output, and we could even get Monty to kind of maybe learn to draw these. But yeah, but so you do have that breakdown.
Yeah, we actually evaluated Monty on it before. And basically the current status is that Monty can learn and recognize the same version of each character quite well, but then as soon as you show a new version of the character, it doesn't do well because they're like the global shape is similar, but the local shape is very different. So it's like exactly showed the need for hierarchy where you represent strokes individually and then the arrangement of strokes instead of the arrangement of all the pixels.
Yeah, the lower level stroke could be a little rotated or, but then I don't know, if we'll be able to do different scales with it. Like what if the lower level object is at a smaller scale or larger scale than what we're used to, or what the higher level model has stored?
You mean if we're deliberately changing the scale or just like natural variation?
Just natural variation, like
Yeah, like we see here.
yeah, like yeah. And
I
also, are these
think it's-
strokes low level enough? They may not be. Like I can see that there could be a circle and then a little thing. I don't know if they're like the most primitive low level ones that we could use. But I guess that's something to find out empirically.
Yeah, I think we'd find out. I think the scale, I don't know, it feels to me like the distortion just from the way people have written it is as much a challenge as the variation in scale, or like it's a similar kind of
Yeah.
magnitude. But yeah, I mean, it's not perfect because I think, again, because it's not native. I think they basically showed these out, the like ground truth characters to people and then asked them, regardless of where they were from, to draw them. So, so not everyone uses the same stroke patterns, and so all of these won't be recorded in the same way.
I mean, the
So as
order
in like,
doesn't matter for Monty, the order in which they were drawn. But there's
no,
a
but as in
significant
like,
amount of
if,
variation within each
yeah, so
stroke.
like, but like, for example, here, someone has used 3 different strokes for this thing. And so, I mean, this comes back to like supervision and stuff, but this would probably be different object, like low-level object IDs from this stroke.
Yeah.
And so that could lead to some issues, but yeah, but I mean, sorry, go ahead.
We might want to find the most canonical version of each letter and then train
Right.
on that.
Just start with at least. Yeah, right. Yeah, right. Or draw it ourselves. But yeah, I think at a conceptual level, I think when you think about this data set, it kind of fits with the mug with logo view, because for a particular letter, you don't have that letter independent of it's clearly a compositional object, but it doesn't exist independently of the sort of binding of the child characters. If that makes sense. It's not like we have, I don't know, generic Korean letter, and then it comes along and it says, oh, okay, this is generic Korean letter with these 5 different strokes. Now it's Korean letter 2. It's like it was always learned from the start this way. Maybe to your point, Vivian, maybe later, like I feel like even though I can't read Hangul well, I can recognize Korean letters very quickly versus like Mandarin or other kind of alphabets that are kind of based around characters. So maybe you do develop a certain degree of like a generic representation eventually, But yeah. But anyways, I just thought this was an interesting example, both in terms of this discussion, but also it could actually be a data set that we consider focusing on first.
Yeah, I think it's a nice data set because it's very simple. It's two-dimensional. It has already a composition defined within the data set. And it's kind of a relatively well-known benchmark that, as far as I know, hasn't really been cracked yet. So yeah, it would be also a cool thing if we can show some results on it.
Yeah. Yeah. And I was thinking in terms of the semantic sensor. So generally, I think if you add an object, like if you added something object by object to the environment, then you can assign unique semantic sensor IDs to it, and it'll track that.
We
So
don't
I don't
need
know.
that for Omniglot. 'Cause we're not putting them into Habitat. It's like a separate data loader, and the data loader knows when it is on which stroke.
Okay, so we kind of, I guess I was just thinking, could we read out what stroke, if we wanted to pass labels for the different strokes, because I think that could be interesting to see what stroke the low-level learning module is seeing. Could we read out what the ground truth stroke is that is currently being sensed?
Yeah.
Okay, nice. Yeah, so if we,
I mean,
as in,
it's
like,
it's not consistent between versions of letters. Like if they drew it in a different order, they will have
yeah, then it's going to be different.
Yeah, like basically you get the color of it.
Right. Okay. I mean, that's fine. It's not a make or break. It's just, it's at least not an advantage for Omniglot then that.
Well, yeah, I mean, first, so with the kind of logos on mugs scenario, we don't have a lot of variation of mugs with slightly different logo placements and stuff on them.
Yeah.
This is a bit of a different task, I think. I mean, if we would start, we could start with just the first character of each, the first version of each character. And
right. In which case we would,
and we would
or we could handpick ones where people did follow the same order. Like there's quite a few.
Yeah, we don't have to start with the generalization task. We can start with doing inference on the one that we learned on.
Right. Or like one or two other variations.
The mug with the logo, we can control the scale of the low level object so that the lower level LM always knows how to recognize that object at the same scale. But here, even the examples that Niels was showing, we have different scales of the lower level objects, like the low level strokes. Some of them are very small, and some of them are large. I don't know if the lower level LM is going to be able to recognize it at different scales, just because Monty doesn't really handle scale well at the moment. Or are we just going to handpick ones with similar scales? And if you show the examples that you were showing again, Niels,
sure.
Let's.
Yeah, I mean, I think as a first example, kind of like Vivian was saying, like I would be tempted to, let's say, start with like these three or something, or 1, 2, 3, those three, which all have kind of.
Yeah.
I mean, we can even like change the order if we need to like, we can kind of hand label and say, oh, this is the upright stroke.
As a very first example, I would start with just one and doing learning and inference on the same one and just looking how the compositional object is being learned and represented.
So are we talking about learning strokes in isolation then, and then learning letters?
Yeah.
Yeah.
That would be our direct analogy to the mug example. So, so we need to be able to display the strokes individually as well.
Yeah.
It seems like this is also a really small data set, and there's nothing preventing us from making our own, like, you know, if we wanted to make.
Yeah, we could make something similar ourselves. It's more like if we want to
eventually.
anything about this, people know about the Omniglot Dataset. So,
Right.
and it already exists, and we already integrated it into Monty, so it would be a bit simpler. But
For sure.
yeah,
I was just thinking in the early prototyping, if we just wanted to go super simple, make a few strokes and make a few letters with, there's like not that many strokes in English either. Like it's pretty, like if I think about the letter 8 or something, it's got 2 small circles. Those are strokes. Like the letter 7's got like a vertical and a whatever. So whether it's omniglot or not, seems like we could have a lot of control over how exactly we want to.
Yeah.
That's
This.
actually interesting. I think, why do we need to do handwritten recognition? Why can't we just do the compositionality on actual typed languages, like just letters from the English alphabet? It still requires.
Well, because we want to learn the strokes in isolation first.
Well, we know we can figure out all the strokes in the English alphabet, like all the vertical lines and circles and all of that. I'm just worried because if you look at these examples that you're showing, like the bottom right and the top left, they have just different scales of the lower level strokes. And
Yeah, I think, I kind of agree that if scale is going to be an issue, then
yeah. But
if
if you have typed letters, how would you get variation into them?
why we were trying to learn the compositionality? Why do we need variation?
Yeah, that's why I'm saying let's just take the first character of each Omniglot character, like the first version of each Omniglot character.
Just
It's the
assume this
same
is
as
the
the
ground truth.
typed letter. Yeah,
I
just
guess
forget about all the versions. Take one version, learn on that version, do inference on that version. It's the same as taking a typed character.
I guess I was thinking because strokes can be directly reused in like the typed versions. So if we wanted to let's say like a little circle or something like that, and that's a stroke. If we were using like a typed version, that circle could be exactly reused at the same scale and different letters or different digits or whatever. But I guess if it doesn't matter that strokes get reused, and that was just like I'm realizing it's an assumption that I didn't voice. But if we wanted strokes to not be completely
Kind of diagnostic of the high level object. Yeah.
because that seems to be kind of the part of compositionality is that like, okay, we can borrow these common things, and then no one piece of it is necessarily 100% identifying of the whole.
Yeah.
Yeah.
Yeah, that's the nice thing about the cups on logos example, where we have the same logo on different objects.
Yeah.
I mean, yeah, I think we can do a lot of different things. The thing that's appealing to me about the Omniglot dataset is it's very simple. We already have it integrated.
Mhm.
It has all the factors. We can just look at the first character, forget about generalization, and just use it to test kind of the plumbing of learning compositional objects. And then from there, we can move on to more complex things like logos on cups or typed characters with straight strokes reused in different objects or different versions of characters in the Omniglot dataset. I mean, yeah, once we can do compositional objects, we can really test the hell out of it and do all these different combinations and test all these different capabilities. But for now, at least what I'm kind of thinking here is like, let's try to find the minimal viable test bed to just see what does Monty learn as a compositional object.
Yeah. Yeah. And I think especially like, I think we're all itching to get a compositional evaluation working during the hackathon. And so maybe one of the main other contenders is the data set that you developed, Scott, which is obviously great for being much closer to kind of what we often describe. And therefore, I think being a better test bed for things like, okay, now we have the logo with the bend in it. And, now the logo is rotated, all this kind of stuff. But it does present some challenges in terms of evaluations and plumbing and things like that in terms of, we definitely don't have access to the semantic sensor for the, like the logo. We don't know kind of which logo is there. I don't think that's like a killer issue because we could, like, let's say we're presenting this one as opposed to Numenta, mug with Numenta logo. We obviously know what the high level object is that we're expecting. And we know the Thousand Brains project logo is somewhere in the visualization. So we can at least just look at, okay, does the learning module, lower level learning module at some points represent TBP logo, whether or not it's always exactly matching when it kind of falls on it. And then there's some kind of unsupervised metrics, which are discussed later in the document, that we could kind of supplement that with, kind of just generally get a flavor of how well it's performing. So yeah, so to kind of summarize that, I think from a kind of supervision and kind of semantic sensor frame of mind, I'm not that concerned about this one. Maybe my biggest concern is actually more about the 2D nature of the logo and the challenges that represents. Because if we learn this logo in 2D, like we don't really have a good way of representing 2D objects right now. We don't extract edges and things like that. And so what we would essentially have is like a kind of a bunch of colors at locations in a 2D plane. That would be the model. And then when we are inferring and it's kind of wrapped around something, we would, I guess it would be able to predict colors again at particular locations following movement, but it wouldn't really be using morphological features of any kind.
That's what the 2D sensor module would be for, right?
Yeah, so we would need that basically. And so in terms of kind of an action plan for the hackathon, I think that puts me in favor of Omniglot of the two. But obviously this is something we still want to return to at some point.
It could be a way to work up to it. So we could test the basic compositional modeling plumbing in Monty on the first version of each character in Omniglot, and at the same time implement the 2D sensor module and potentially and think about attention mechanisms and stuff like that, and then test on this data set afterwards.
Yeah. Yeah.
If we make different arrangements of the 3D objects in a scene, doesn't that solve the problems of, like, because we have semantic sensor and it's just we already have models of the objects. So is that what you have? Okay, sorry.
Yeah. No, it's a great question. So yeah, so a potential data set, which I've provisionally called Inception YCB, is that we kind of embed certain YCB objects in other YCB objects so that they're kind of partially visible, which, yeah, kind of like you suggested, Rami, so that this was meant to be a dice. I don't know what happened, why that got deleted. Anyways, but
Wait,
so...
dice just turned into a strawberry?
Well, I had two... I had the dice, and then I had the strawberry, but then I wasn't happy with the rotation of the strawberry. So I thought I deleted this and put in this new one, but clearly I deleted the other one. Anyways, but yeah, exactly like you say, Rami, because then if we construct them in Habitat, so we wouldn't construct them kind of in some, Blender or whatever. We would literally kind of construct them in Habitat by adding the objects in series. Then we would have the semantic sensor information. We would also have morphological features because everything is still 3D.
Yeah.
And then, yeah. So this would be another option.
Or
I think the main...
another option is the data set that Rami put together and that we set up at last year's hackathon of the dinner set.
I think the main issue with that one is, I think we would want Scott's saccade policy to be working well, because those kind of objects are sort of separated in space. And so to saccade onto them,
Wouldn't it
The
still?
viewfinder would still.
Why would the viewfinder make a difference between that?
like if we're on the bowl, how do we get onto the mug? Whereas like here, we would smoothly move over both objects.
You mean before we have the saccade policy?
Yeah, before we have the saccade policy.
Oh, okay. I thought you meant the saccade policy wouldn't work with it.
Oh no, sorry. As in, we would want the saccade policy in order for it to work.
Okay, I understand now. Okay.
I guess in theory, you could kind of crawl over the table, but I just feel like it's going to go everywhere.
Yeah, I guess just to note that if we're talking about hackathon, saccade policy during hackathon, I think inhibition of return right now is just going to more likely zip between objects, like alternate observations on objects than it is, stay on one for a while and then move to the other. So I'm not sure that that's going to be different in, 5
yeah, like in the
5
short
days'
term.
time.
Right.
Well, we could
Yeah.
also revise the policy so that, it does a few steps on one object and then just moves on to the other object.
Yeah.
Since we're doing supervision anyway, for the, what is lower level and what is higher level. But I wouldn't do the dinner set because we wouldn't have the semantic sensor. But if we have
Yeah,
those
right. We did the same issue.
datasets, or we just have like 3 objects like in a triangle or like and then we just change them, we would have different arrangements. We could control the scale and we could just move between the objects and build the compositional object.
Yeah, I think the main thing is it would just be nice to have like a clear concept of kind of child and parent. But so that like, yeah, it's not just 2 objects next to each other, but it's kind of, but yeah, it could be a big triangle and a small circle or sphere or whatever. But yeah, so I think the main challenge with this one is it would just take a bit of tinkering to figure out the positions and stuff that like the locations that we need to initialize the objects in order to have them look like this. But maybe it's the kind of thing where we could import the models into something like Blender based on their dimensions and stuff, work out what the relative offsets between them needs to be, and then kind of one-shot it in our configs.
I think this one is my least favorite, but if we do go with it, couldn't we just use the multi-object setup we already have? And then say the compositional object is how the multiple objects are arranged in the scene. And the child objects are the individual YCB objects.
Yeah, I mean, we can, I guess. Yeah.
Delicious.
There we go.
I
Yeah, I guess if we use the distant agent, it probably could saccade between them. Because the surface agent's kind of stuck on an object once it's on it, like a continuous surface. But yeah, I guess the distant agent
Which
could
one
do
do
that.
we currently use on that?
I think it is the distant agent. Yeah.
And do you remember if it moved between objects?
Yeah, because we were trying to at one point implement a policy that prevented it from doing that.
Okay.
But yeah, that's a fair point. That yeah, we would just have to adjust it slightly because I think right now it adds objects randomly. So we would just need to, I mean, that would be a pretty simple change, but we would just say kind of like, okay, this set is compositional object A, this set is compositional object B. And I mean, in our definition of the object, there's nothing saying that void cannot be, like, that has to be continuous in the void, right? It can just be, they can be spread out.
No, not in the definition of the object. It's just practically in terms of the policy that right now, every time it goes into the void, it's like, oh, and then it goes back. But so that means that if the objects aren't continuous, either through like occlusion in visual space or their surfaces touching, if it's the surface agent, the policy won't kind of go from one object to another.
Is there a problem with supervising the policy, like I mentioned? Like after terminal condition on one object, so we just manually move the agent onto another object.
I guess it's just, I feel like stuff with policy is always surprisingly difficult to implement.
Yeah.
Doesn't seem to me like something that would be easy to add, but could be wrong.
Okay.
But yeah, I don't think it's like a issue by principle or whatever. Because obviously, yeah, we're introducing supervision and stuff here deliberately. Okay, yeah, I think this is the main thing to talk about and for us to just all think about a bit, and then that can be maybe something that we decide over the next couple of days or on Monday is which data set to work with. And but yeah, I think my preference right now would probably be Omniglot.
And then did you have some more on like the supervision and evaluation part? I guess we already talked about most of it.
Yeah, so
Yeah.
on the evaluation, nothing kind of crazy, but just yeah, like just to kind of show more concretely, in case it wasn't obvious, like in terms of why it would be useful to have the semantic sensor information, is just that we can have plots like this then for both the low level and the high level learning module. And I guess for the high level learning module, actually it'll just be during a given episode, it'll be the same object, compositional object being shown. But it would be interesting to be able to see, okay, you know, the low level learning module, oh, now it recognizes its stroke so-and-so. It's like, oh, interesting, it thinks it's stroke so-and-so. And it's like, oh, that makes sense if it rotates that stroke. Just stuff like that is why it would be helpful to have that that information. A few ways we can get around that is, so one is just like the thing that Hojay added. We can scrub through, and I think this is probably good enough for the hackathon, because it's going to be only a few episodes anyways that we're dealing with. We can scrub through and see what the sensor modules are actually seeing, and just as a human kind of manually say, oh, okay, yeah, it thinks it's on so-and-so stroke, and that's clearly what's being observed by the sensor module. If that makes sense. And then I just had some notes on, like, in the longer term, I think this will become more important, but in terms of other metrics for performance, looking at kind of prediction error is generally, I think, just something that will be useful, particularly as we get towards, like, you know, eventually we want it to discover composition without us telling it what that is. So the semantic sensor isn't just a case of like practicality. Eventually it's just something we don't want to rely on anyways. But you can imagine, kind of, if the representations are good, then obviously the prediction of what the learning module is going to see and what it actually senses is going to, those are going to match well. And so that prediction error on each step is going to be low. And so this is just showing an example where kind of at the start, maybe the most likely hypothesis is wrong. So the kind of prediction error is high, but eventually the most likely hypothesis that kind of emerges is quite a good one. And so we get very low prediction error, and then we move on to a logo. And in this case, because we don't have a compositional representation, suddenly this spikes. But if we know that we it's the mug with logo, then we would expect this to be lower. And this is where we could also look at, okay, like to your point earlier, Scott, like if we just have a high level learning module that learns mug with logo as like a giant object, but it has a course level representation, it might kind of do an okay job, but it would still be kind of up here. Whereas if we have a true compositional representation and the high level learning module can work with the low level learning module, and then the low level learning module, if we look at its prediction error, it might be much lower. And it could actually, the high level learning module could tell the low level one, we're moving on to the logo, kind of get ready to make predictions at your level of resolution.
Yeah, I think that's a great idea. I think we should try and add prediction error as one of the measures. Especially, it will be generally a nice measure also for symmetry and things like that, to know what's the prediction error of the most likely hypothesis at any step. Because like even if the pose is off or something, if it's symmetric, it will have a low prediction error, and that's
Right.
ultimately what matters in any application, whether you can predict what you're
Right.
going to be sensing.
Yeah.
And if that's low, it doesn't even really matter anymore. Like, what's the semantic sensor saying, or how did we
Exactly,
initialize the
yeah.
objects and stuff like that. So yeah, I wouldn't say this is like a long-term thing. I think this would be a great thing to add during the hackathon. And yeah, I think generally, I mean, yeah, we will want to manually inspect what's going on and all that, but it would be nice if at the end of the week, if that is a project we pick, if then we have like a benchmark thing with measures that we can rerun and have as a test bed to see how those measures are affected by any changes we make in the future.
Right. Yeah, and I think that's what's nice about it, is it's like this would be useful information when you look at it like this, kind of broken down across the episode. But the mean prediction error would also be an interpretable kind of summary statistic, which, as you say, that's something that we could have in a table, and we kind of see how that changes as we introduce new architectures and all that kind of stuff. This is just for kind of clarity, just showing an example where predictions are particularly bad. But yeah, so that was most of that. Oh yeah, and then the last kind of figure I had was just on this kind of attention type thing.
Sorry, if we
Yeah.
can talk briefly a bit more about the evaluation measures.
Yeah.
I think one difficulty, if we want to evaluate the representations of the lower level learning module, is that it will change throughout the experiment. And it's not like with high level one where it reaches a terminal condition and then it'll be like, oh, did it classify it correctly or not? But we need to think about, like, when do we measure it? How much time do we give it after moving on to a different subpart? How confident does it need to be? Like, I think that will be one of the major challenges with modeling compositional models. Right now, we have the same kind of confidence threshold for the lower level model to send something to the higher level model as we do for for any model to kind of converge and terminate the episode. So one, we will have to think about the terminal condition and how to adjust that. Because right now, if we have a hierarchical experiment, we basically, the first time we're sending an observation is like when the experiment ends. So
Right.
we have to rethink that, and then also rethink, like, at what points do we check the performance of the lower level learning module, and how do we make sure that the higher level model gets enough input? Like, given that it takes some time for the child object to be recognized, after it's recognized, you still have to kind of keep moving on it or integrate that past information into the model. So yeah, I think in my mind, those are kind of some big questions that would be good to figure out.
Yeah. Yeah, and especially I think the first and the last one. I guess the second one, I feel to a degree, like for example, the prediction error, like if we just measure it across the episode, it should always get lower if it's doing a better job of like even if it's going to spike for a bit when we go into a new object, if the composite, like if the hierarchy is working right and the high level one's telling the low level one, oh, I think you should be on this object, kind of ramp up your evidence for it, then we should see that kind of metric come down. And then of course we can examine it as well and see that like, okay, yeah, it's the number of steps before it drops.
So you mean for the lower level, like basically for the compositional objects, we won't be looking at ground truth anymore, just prediction error?
At least in that, yeah, if we're using the prediction error. And then if we do have access to ground truth, then we could look at kind of like what proportion of steps does the kind of label in the low level one, like the MLH in the low level, match what's actually being observed. And so like 75% would probably be pretty good, whereas
Yeah.
like 10% would be pretty bad, like it's taking forever to and those are kind of measuring the same thing, but one's like a supervised and one's an unsupervised measure.
Although that metric can be kind of hacked by adjusting the policy to just stay on that child object after it's been recognized.
Yeah, right.
That's true.
So maybe, and I mean, prediction error can definitely be like, I think that's something that people, whenever Carl Friston explains pre-energy principle or whatever, people are like, oh, but then wouldn't you just like go into a dark room and close your eyes because then you can like perfectly predict everything? And then he's like, well, yeah, that's what people tend to do for 8 hours a day. But before they start predicting hungry. I don't know. Anyways, tangent. What you gonna say something, Rami?
Yeah, just a quick question. Why do we need to evaluate the low level islands if we're just getting the high level correct?
Well, because I think we want to see, like, we just want to understand how the system's working and that it's working like we think it is. I think
Yeah, but
this
that's-
Yeah, I
if
think
we
it-
only look at the high level, that we convince ourselves, oh yeah, everything's working, and then it turns out it's doing something really strange.
Well, I think it's a fair question. We might not need to look at the ground truth comparison to lower level, and it probably won't be realistic in more complex scenarios very soon anymore. Like it might just be that we use prediction error at every level and then only classification error at the highest level. Or in the very long run, just look at how well the system is interacting with the world, like the motor outputs essentially. But yeah, I think like Niels said, as a first
Yeah.
thing, it'd be good to just kind of for us to see what's going on.
Yeah, I think this would be nice to be able to like inspect and figure out that it's doing the right thing. But like I'm talking about more of a benchmark. So that does the performance of the lower level LMs go into the benchmark, the total number of like accuracy that we need to report for the compositional? Because I could take a
Prediction
example.
error would, because that's kind of where it's like, if we want to know what we're going to be seeing when we go on the logo, we can't rely on the high level one. Otherwise, again, we're just trying to learn like a giant supermodel of everything at one level. So I think if we want to see compositionality doing something kind of useful and interesting, then it doesn't necessarily need to be in a supervised way, but I think we do want to measure and report how well the low level learning module is doing.
Yeah, another measure
Like
I
what
would
is its
add.
prediction?
Yeah, another thing I would measure in the lower level model is how many of the steps it actually sends something to the higher level model. So basically, trying to get it to be confident enough most of the time to send information up. Because maybe it's not something to be concerned about, but that's kind of my main concern at the moment. That it will just take too long before it gets confident enough to send something up the hierarchy. And that's something we might want to try and improve in the next months.
Yeah.
Yeah,
Yeah.
then
And then,
sorry, go.
oh, I was just thinking, yeah, I mean, we can see how the hackathon goes, but if we focus on adding the prediction error metric, we potentially try and do both Omniglot and Scott your logo with objects data set, because yeah, well, I guess yeah, there's still the 2D stuff.
We could have two teams. One pitch could also be to implement the 2D sensor module, and then at the end of the week it's evaluated on the logos on mugs.
Yeah.
I don't think
Yeah,
this
true.
is a topic that like a huge team can work on, because it's hard to break down.
Right. Yeah, sorry, Rami, were you saying something?
That's not a point. We could also break into teams and do the same challenge at compositionality, and then
Oh, just see who solves the brain first, basically.
with those.
Yeah,
Who solves
adversarial.
that?
I mean, since there are, I don't know, trophies at the end anyway. So.
Right. Who gets the lowest prediction error? And someone will put their Monty in a dark room and win. Sorry. Yeah, just the last thing I'd kind of drawn a bit on was the this kind of attention type question stuff where, you know, from the sounds of it, I think we agree that, yeah, basically any learning module in the hierarchy, at least to a degree, can in theory have a model for a particular object. So as in, we'd have TBP logo here, TBP logo here. We'd have mug here, mug here. We definitely have mug with logo here. We potentially have mug with logo here as well. And then it raises the questions about kind of like we were talking about at the start, how we learn that, and also how those we get kind of different representations, given that at any given point in time, the kind of sensory input is potentially consistent with multiple ones of those. Like if you're looking at the kind of surface normals and curvature and stuff like that, then maybe you'd recognize, oh yeah, this is part of a mug. If you're looking at the edges and things like that, then maybe you'd recognize it's a logo. I think, yeah, personally, this isn't something we need to solve now, but it's probably a kind of a multifaceted thing based on things we've discussed in the past. You know, different sensor modules would focus on detailed versus coarse stuff, and that would be reflected in what the learning modules learn. We've also talked about how some learning modules might get more input more consistent with 2D representations, so both the features but also the movement information coming in. And then Jeff talked about some stuff around how we could kind of window attention, which also ties into kind of policies that that would affect kind of, okay, this learning module is mostly getting kind of a narrow input, and so it focuses on kind of the child object and things like that. But yeah, if nothing else, I just thought it was worth us kind of being aware that, to a degree, this is still like an open question and something for us to think about. And yeah, that's basically everything I had for today.
Yeah, I mean, not even just that it's consistent with both, but also if the lower level model is trying to recognize the logo and it moves onto the cup, there'll be something that's inconsistent with the logo model, and we're not really gating that input right now. So like we're saying, oh, we're not on the logo anymore, and it's not like we're now in the void like we currently are with the YCB objects. If we move off them, we just don't send it to that learning module anymore. So I think even just inference on the child object, disregarding that it might be consistent with two objects, is difficult, because it will get all the surrounding inputs as well that are not on the object.
Yeah, as in you're saying, if we move on to off the logo and onto the mug body, but we are narrowing the attentional window.
If you don't have an attentional window mechanism.
Okay, yeah, because then wouldn't it just then be, okay, now I'm on the mug?
I I guess so.
Especially if it knew the mug and the hierarchical, the compositional object had learned mug at locations, then it could also help get it in.
Yeah, you're right. It shouldn't even keep thinking that there's a logo. It should just be like, now I'm
Yeah,
not on
it's kind of that
logo.
out of reference frame movement thing.
Yeah, you're
which-
right. Yeah.
Which is why, yeah, there might be still something to return to at some point. Cool. But yeah, it feels like we've at least got enough of an idea to start on something next week. I'll still try and clean this up a bit, so that I can share it. But I don't think there's any secret knowledge in here that's either something that you guys haven't already thought about or we'll kind of work through next week.
I may have missed, what are we doing next week for, like, we're all each going to present an idea, or as like an actual presentation, or just, just look through the spreadsheet and go through the ideas that are there?
Yeah, so the idea is that everyone pitches a project idea from that spreadsheet. I mean, ideally, not more than one per person, but if you really have two great ideas, I guess that's okay too. But try to figure out which one could be the best to pitch. And then you just do like as short as possible pitch of that idea, like 2 to 3 minutes. You don't have to prepare slides or anything. Focusing on like what will it be about, why is it important to do that, what would be the impact of it, and the kind of positive outcomes. And yeah, after all the pitches, we'll see who might be interested in which project and try and form groups around them.
Some of these projects are very involved that maybe, like if I work on the stacked one, maybe it requires 2 people to work on this full time, or 3 people to work. Like some of these projects may not. I don't know if I want to give my full time to the compositionality one, I might not have time to pursue another one. So is this a rule that everyone should have one project, one idea?
Yeah, you should have one main project. You can kind of help out on other project if people want to consult you for your opinion, but you shouldn't be like doing major work on multiple projects.
Okay.
Cool. That's
And yeah, I guess with the pitched ideas, kind of try and think about whether this is a good project to do with like a 2 to 3 person team.
yeah, to make the most of the teamwork nature. Yeah, that's everything for me.